All right. Well, hello and welcome to our session STG214 on how Netflix manages exabyte scale data using Amazon S3 storage lens. I'm Roshan Tekekunil. I'm a product manager with the Amazon S3 services. And joining me now on our session today is my colleague, Christy Lee, Principal Solutions Architect with Amazon S3, and our friends from Netflix, Austin Keene, who's a software engineer at Netflix, and Biling Wu, who's a data engineer with the Netflix data science team. Cool. So just some logistics. We have a lot of content to cover today, so we will not be taking any questions during the session, but my colleagues and I will be available in the hallway after the session to answer any questions that you may have. Okay. So we'll start with a quick look at the agenda. We have broken the session into 5 parts. I'll start with a quick overview on the Amazon S3 Insights portfolio and double-click specifically on S3 storage lens, which is the focus of our session today. Then I'll invite Austin and Bea to walk you through some of the Netflix use cases, how they leverage the S3 Insights services to optimize their storage deployments. Then I'm really excited to talk through some of the announcements we made yesterday on S3 storage lens that further enhances your optimization workflows. And then finally, Christy will be running us through a demo where we'll see all of these new features in action, live in action, solving real performance and cost optimization use cases. Okay. So before I transition to our first section, just a quick show of hands. How many of you are familiar with S3 storage lens or any of the S3 Insight services? Okay. Cool. I see around 25 to 30% of the room. That's awesome. I think by the end of this session, I'm hoping everybody will learn about S3 storage insights, S3 storage lens, and how you can utilize these services to optimize your storage. Okay. I'd like to first establish why you want insights, right? As you're storing data, where you store your data and how your applications access that data is critical for various reasons: your cost profile of your workload, the performance profile of your workload, as well as the security posture of your data sets. Therefore, it's critical for you to understand how your data is being stored, where it is being stored, and how your data is being accessed. As the saying says, if you can't see it, you can't change it. In this case, you cannot optimize it, right? Therefore, with S3, we have built a number of services that gives you this visibility on both your storage and activity metrics, both at an organization level, aggregate metrics, and down to very granular insights at an object level or at a request level. Okay. So let's start looking at the insights portfolio. First up, we have S3 storage lens. This is our observability tool that provides daily insights on both storage and activity metrics in one interface. Right? Now, this is a recommended first step for you to start understanding how your storage is deployed, how it's being accessed. We make it very easy for you to use. You get a default storage lens account as soon as you create your first bucket. And you have free metrics, around 60 plus metrics, that helps you understand how your storage is deployed. Okay? Now, if you need more granular data beyond the organization level and bucket level, we have services like S3 metadata and S3 inventory. Now, this goes down to an object level report, right? So you get a list of objects and the associated metadata. And with S3 inventory, you get this on a daily or a weekly basis in a CSV or Parquet format. Right? Now, if you need more real-time data, last reInvent, we launched S3 metadata, which gives you near real-time information of all of your objects and your metadata. Right? And S3 metadata is delivered in managed S3 tables, which means there's no additional processing. You can directly use your preferred analytics tools to start querying and discovering your data. Now, similarly, If you're looking for granular request level information, you can turn on S3 server access logs. This will give you detailed records of each and every request made to your bucket, right? And then finally, we have Amazon CloudWatch, which is our monitoring service. This gives you visibility of your storage metrics in context with all of your other AWS service metrics, as well as your own application metrics. So here you can do near real-time analysis, create dashboards, set up alarms, essentially anything you need to do with your operational workflow. Okay. Now let's take a deeper look at S3 Storage Lens and how customers use it. Now the primary use case with S3 Storage Lens is cost management, right? So questions like, which are my largest buckets? Which are my largest prefixes? How has the storage been growing over time? Do we see any anomalies, a sudden increase in storage in any of my buckets or prefixes? That's the kind of questions you can get answered through Storage Lens. The second most common pattern is around access. Which of my buckets and prefixes are hot? Which of them are cold, right? You can find out which buckets and prefixes are getting a lot of requests, which of them are not getting as many requests and therefore needs to be moved to a colder tier. Those kind of questions can be answered through Storage Lens. Third, around performance monitoring. Now, you can answer questions about which buckets are experiencing 503 errors, that is our throttling errors, or 403 authorization errors. You can identify these buckets or prefixes. These are potentially slowing down your applications, and those are the ones that you want to focus on. And finally, we hear from customers around security audits with Storage Lens. So you can ask questions like, which of my buckets have unencrypted data? Or which of my buckets do not have versioning turned on, or do not have adequate replication rules? Those are the questions you can get answered through data protection in Storage Lens. Just to give you a flavor of some of the capabilities in Storage Lens, if you log into Storage Lens through S3 Console, you'll first come up with this overview page where you can see a snapshot of all of your data across your entire organization. So this is across multiple accounts, multiple buckets in multiple regions. You'll get a summary snapshot here. You can then filter by categories of metrics. So you have performance metrics, cost optimization metrics, and you'll get all of those metrics categorized in this view. You can then start drilling down from here in Storage Lens. You can go down to account level metrics, region level metrics, storage class level metrics, and what you're seeing here is a bucket level metric, right? So this here is the top 10 buckets in my account, the very same metrics distributed across these 10 buckets, right? And then finally, in Storage Lens, we have an advanced tier. If you turn this on, you'll get additional metrics and also advanced features like prefix level metric aggregation. So what you're seeing in this example is the top 10 prefixes by size across all of my buckets, all of the same storage metrics and activity metrics distributed across these 10 prefixes. So rather than me talk more about how customers use Storage Lens, we have Netflix here, who are one of the largest deployments of storage across the globe. And we learned from Austin and Bea how they use Storage Lens and other insight services to optimize their storage. Austin?
Hi, everyone. My name's Austin. I'm a software engineer at Netflix. And for those of you without an internet connection, Netflix is a streaming company. We do everything from F1 reality TV to Stranger Things. So when we talk about tracking our data, let's talk about why that's difficult in the first place. We have over 2 exabytes of data stored in S3, and that's spread out across 3 major use cases: big data, media, and ML. These use cases have different access patterns. They may be accessing abstractions built on top of S3. They might be these big multi-tenant buckets where different teams own different prefix paths. So it really quickly gets quite complicated to provide org-wide visibility into usage and cost. So what do we do about it? We take the data, the storage lens information, and we ingest it into Apache Iceberg tables. We aggregate all of that into high-level growth trends, and then we materialize that for our application owners. So this is an example dashboard we have. This is the high-level usage dashboard that we use to get a sense of the general health of S3 at Netflix. We'll also create more tailored dashboards depending on the use case. So there will be a media dashboard, a big data dashboard that lets application owners understand what's going on at a high level. But not everybody likes getting DMs from me on Slack about their S3 usage, so we have some better tools as well. This is where the growth tracking comes in. What we do is we provide automated alerts for application owners. So when their storage footprint crosses certain thresholds, they'll get an automated message, and that takes them to fine-tune dashboards. So as you see here, this user got a Slack alert. Their growth crossed over a certain percent over a period of time, and then they can go to this dashboard to take a look at what's going on. As I mentioned, we might have these really large multi-tenant buckets. Different teams own different prefix paths, so it's really important that they get some low-level data and can really dig into what's happening. This mechanism alone has caught over 500 petabytes in unintended storage growth. That might look like media buckets where studio partners just dump assets and forget about it. It'll be misconfigured janitors where tables are racking up costs, but nobody's using them. Just recently, we had a 6 petabyte growth in a log bucket for containers, and the team that owned the bucket didn't even really know about its size until we reached out to them. So just having some simple mechanisms that informs people about what's going on is enough to start really saving on costs. Another thing that we do with storage lens data is optimize the data placement. You might hear that data has inertia. So once you put a bunch of data somewhere, it's really expensive and time-consuming to move it somewhere else. And so if you're an application owner and your data is in S3, you're going to point your application at S3 and you're going to call it a day. And for the majority of use cases, that works totally fine. But if you have low latency or high I/O requirements, you might run into some trouble. And we saw that with our ML training jobs. When we were first launching our ML training platform, we saw these jobs have really long cold starts, and that correlated to idle GPUs. What was happening is S3 was throttling them as they were trying to hydrate data. And so in this effort to save a little bit of money on storage, we ended up spending a lot more money on idle GPUs. So what we did is we looked at the request and throttle metrics from Storage Lens to figure out which applications were having problems. And then we placed them on more performance storage like EBS or FSX Lustre. That eliminated our cold start times, and so we spent a little bit more money on storage and ended up saving money by optimizing for GPU utilization. Another thing that we do is we take all of this information and we turn it into platform insights. We take all the Storage Lens data and we vend it through internal APIs to our platforms. As I mentioned, we have a lot of abstractions built on top of S3. And so we run into this problem where how do you tell a user that their S3 bucket is growing in size when they didn't even know they had a bucket in the first place? That's where all of this comes in. So as you can see here, these are two different dashboards that people will use to interact with their applications. We take the data from Storage Lens and we put it right into the UI so they don't have to go looking for this information. We find that application owners understand their data best, and we don't want to be prescriptive about how they use S3 or whether or not they use S3 at all. We find it works really well. So what we really want to do is take this data, make it available to them, and let them make the best decision. So if you're not paying attention to me up until this point, now is your time to check in. I'll tell you how I think you should adopt Storage Lens if you're not using it today. The first thing you should do is usage trends. Take the data, put it into a dashboard, and review it periodically like you would with any other on-call review. Just having some group that looks at this information and follows up on it is enough to already start affecting change. But if you're a little bit bigger than that, then you'll want to invest in automated growth alerts. You want to take this information and you'll want to send it to the application owners who it's relevant to, so they don't have to go looking and you don't need some central authority to manage all of that information. Finally, if you're even larger, that's when you should invest in platform-level insights. If you have a lot of abstractions and platforms built on top of S3, you want to take the information you have and you want to provide it somewhere so it's easy for everyone to access. So that's a brief overview of all the things we're doing with Storage Lens. I'm going to hand it over to my colleague B to talk in more detail about what we're doing with S3 telemetry.
Hi. Thank you, Austin. Hi, my name is B, and I'm a data engineer at Netflix. So while Austin's use cases are around the broader growth and metrics tracking for our S3 ecosystem, my goals, unfortunately, are specifically for cost and efficiency. There are 3 key areas where deep insights make tangible differences and where Netflix has chosen to focus on. First, we aim to provide visibility into the cost of each prefix for the top 250 buckets across our ecosystem. This allows us to pinpoint exactly where the spend is going and helps us identify opportunities for optimization. Second, we aim to offer advanced analytics for Iceberg table storage and prefix usage. This means that we can analyze how our data is structured and analyzed. And we use that information to make, hopefully, smarter decisions about our storage. And finally, we have millions of Iceberg tables in our S3, and all that data is stored in S3. So we aim to deliver clear visibility into the costs associated with those tables themselves. And so at the end of the day, there's not too many surprises, and we can manage our resources more effectively. So this portion, I'll actually just do a deep dive into how we construct these cost metrics for all the prefixes to an unlimited prefix depth as a foundational data set. I'll take a step back here, and to enable efficient analysis of our storage utilization, we need to track storage metrics at all prefix depths. So on the right here, I have a sample file directory representing what we're dealing with and what we're hoping to achieve. So we have bucket A with prefixes A to D and any number of objects all in between. And so just to reiterate, the goal is that for unlimited prefix depths, we can understand what the size and cost is at each depth. You might be thinking to yourself right now, B, this seems to be exactly what storage lens is for. Why are we rebuilding the wheel? Well, you wouldn't be wrong. When we started this work, my team and I evaluated several S3 services that may fit our needs. So at the time in 2023, we faced a few limitations that caused us not to choose storage lens. First, storage lens did not include prefixes that represented less than 1% of the total size of the bucket. This was an issue because some of our buckets are really big and fairly multi-tenant. So for example, a prefix could represent a large portion of an Iceberg table, but did not yet meet the 1% requirement for the entire bucket. Second, our storage lens had a max prefix depth of 10. Again, this was good, but not yet enough for us. Finally, as many folks in this room know, cost is not only by size, but intelligent tiering and storage class. So these, at the time, storage lens lacked this dimension and granularity, and because of these three gaps, we've turned to using S3 inventory and S3 access logs. I'll now go into how we join these two data sets to get cost. I'll bring back my file directory here. So as I've said, this is the file directory that we could be dealing with, and I've turned it into a pared down version of what you might be getting in your S3 inventory report, including size, prefix path, intelligent tiering, and storage class that I've combined into a very convenient field for us. On this slide, I provide an example of how we created that prefix rollup from the inventory report. Like in storage lens, each row represents the storage class and total size. We have the total recursive cost, which is the cost of that prefix and everything underneath it. So at prefix depth 0, this is the size of the total bucket. And we also have exclusive cost, which represents only the objects in that level, non-recursively. With this prefix rollup, we can then apply pricing at intelligent tiering, storage class, and size to get the total cost of the bucket with each prefix up to an unlimited depth. Okay, so now we know the cost of the prefix. We want more. We want to save real dollars, B. We want that curve bill to go down. I can relate. Unfortunately, a very easy way to save money is to delete files. But how do we do that without deleting important files? This is where the server access logs come in. In this diagram, I've highlighted how we join the server access logs to that prefix rollup that we just built to understand which files are used and which files are not used. So based on this example, we can see that prefix C has been accessed pretty recently, and we can make the recommendation to keep prefix C. Yay. However, we see that prefix B hasn't been accessed since 2010, which is about 15 years ago. And we can make the recommendation to delete this file. I know this is only 30 megabytes, but at a larger scale like we have at Netflix, this can present a big opportunity size for cost savings. Now, if you were to take this back to your own organizations, I would make a couple of recommendations. You should understand the type of data in your bucket and take all of these recommendations with a grain of salt. So some files may not be accessed all the time, maybe every 6 months, annually. There are a couple levers that you can pull on to make this work for you. One example is maybe expand the time range at which you call acceptable access or recent access. Another way is to possibly change the recommendation that you offer. So instead of offering to delete a file, maybe you can ask your data owner to move it from frequent tier to cold storage. That's an option. One of the ways that we've implemented this access-related recommendation is through Iceberg table storage. So I'll take a step back here and bring back just our prefix rollup. As I've said before, this is a foundational set. Many use cases are unlocked now that we have this kind of granular information. We've mostly been exploring prefix cost, but this can be easily extended to Iceberg table cost. For example, we have the Iceberg partition inventory that tells us table A has prefix B and prefix C as partitions. Now, we can easily link this back to the rollup. Well, there we go. So not only can we tell what storage tier each partition has, we also know the size and cost of each partition. And now when the sum of the partitions are put together, that's the cost of the table. Layered with access logs again, we can then extend our access-based retention recommendations to a specific Iceberg partition. I'll reiterate what's been said before and leave you with some key takeaways about these analytic tools. S3 inventory, as Roshan has pointed out already, is a periodic snapshot, and it's great for granular analysis at the object level. Server access logs capture every request made to these S3 objects and serve a large variety of use cases. S3 storage lens is for the big picture. They're for growth tracking for your whole organization. Ultimately, these tools serve to complement each other, and it gives you a comprehensive view of your S3 environment, from the smallest object to the largest trends. The suite of storage insights are incredibly powerful tools to help ensure this health of your organization from the megabyte to exabyte scale. A special thanks to our teams back at Netflix, and I'll pass it back to Roshan for some exciting new features.
Thank you. Thank you, Bea. Thank you, Austin. So hopefully you get an idea of how Netflix is continually optimizing their S3 storage, and you get some ideas on how to optimize your storage deployments as well. Next, we'll transition to some of the new announcements we made yesterday with the new feature launches on S3 Storage Lens. Personally, it's quite fascinating for me to hear from folks like Bea and Austin on how our customers are using our services to optimize their storage. And my team and myself, we have been working very closely with Netflix and other customers to understand what their end-to-end workflow is and to further streamline their optimization workflows. So we have been focusing on three primary areas. Number one, on visibility, precisely what Bea was trying to explain here, that folks like Netflix need metrics for all prefixes in their buckets, not just the top prefixes. So that's been an area of focus. The second one is around performance insights. Customers want to understand how can they improve their application performance when it's accessing data in S3, right? Very much like the use case Austin went through around machine learning or data analytics. You do not want your compute waiting on getting data from S3. That's expensive. And finally, ease of analysis. We have a lot of metrics. We have a lot of dimensions that you can slice and dice it in Storage Lens, all the way from organization, accounts, regions, buckets, and prefixes. How do we make this analysis simpler for you? So we are really excited by the three launches we made yesterday. Number one, in Storage Lens now, you have a new capability. It's called the Expanded Prefix Analytics. Essentially, you can now get metrics for all prefixes in your buckets in Storage Lens. Number two, we have added new performance metrics. And very specifically, these metrics are around how your applications are accessing your data in S3. It gives visibility to that interaction, right? So the idea is it will help you identify any inefficient requests and eliminate those bottlenecks. And number three, around ease of analysis, we launched a capability to now export your metrics directly into S3 tables These are managed S3 tables that are automatically created, and you can start querying your data right away using your preferred analytics tools. I'll walk you through each of these and their use cases. First up, we have expanded prefix analytics. We went through this use case where Netflix wants to understand at a prefix level, what is the storage consumed by each prefix, what is the activity, the request cost per prefix. Similarly, we have customers asking questions, hey, which are the prefixes that have had no activity in the last 100 days, right? Those kind of questions require you to have precise knowledge of each and every prefix and the metrics for each prefix. So yesterday, we launched a new capability. It's called the Expanded Prefixes Metrics Report. This is available in your advanced lens storage tier. It's at no additional charge. Woo! There you go. And just to give you a comparison of the two reports, you have the default metrics report with your storage limit, the 1% size limit, and your maximum prefix level of 10. That gives you roughly around 100 prefixes per bucket today. With the expanded prefixes metrics report, there is no limit on storage size. You get up to a maximum of prefix level depth 50, and you can get billions of prefixes per bucket. There's no limit on the number of prefixes. So this is now available at no additional charge for you. Okay. Second, on performance insights, we've added 72 new performance metrics to Storage Lens Advanced tier, again at no additional charge. Okay. This brings the sum total of metrics in Storage Lens to 198. Now, as I mentioned, these metrics are specifically designed to show you how your applications are interacting with your data in S3. Right? We have broken those metrics down into 3 broad categories. I'll go through these. First up, we have a category of metrics that will help you optimize your application performance, right? So an example of that is the new request and object size distribution. So now you can view in Storage Lens in each and every prefix how your objects are distributed by size, ranging from 0 kilobyte all the way up to 4 gigabytes and above. Right? Similarly, you can see the distribution of requests that are coming into each and every prefix. Right? If they are small requests ranging from 0 kilobytes, again, the same bucket categories up to 4 gigabytes. Now, why is this important? If you're seeing a lot of small requests or large requests, that is not good. That means your application is not getting the best performance. Right? Now, the reason could be you have a lot of small objects in your prefix or in your bucket, right? Now, the easy remediation there is to potentially look at compacting the small objects into larger objects. You get better throughput with the larger object size, right? Now, you might have right-size objects in your buckets and prefixes, and yet you're seeing small requests or large requests. There's the potential for you to investigate more on the client side if there's room to improve your applications. Another example is a new category of metrics we have introduced called concurrent put 503 errors. Now, as the name suggests, it's a category of 503 errors which are throttling errors, but these are generated when multiple applications are writing to the same object. Right? Now, these can be self-remediated by proper back-off mechanisms, or if it's a multiple writer scenario, you want to build consensus mechanisms to avoid these kind of errors. Again, these are a category of errors that are slowing down your applications, and you can easily avoid these. Right? The second category of metrics are directly addressing latency and costs, and these are what we call network origin metrics. So now you can see in Storage Lens what is the origin of the request coming into a prefix. Is it from an application that is running in the same region, in the home region as the bucket, or if it is coming from another region, cross-region request. That's what you're looking for. You want to avoid cross-region requests where you can, because it's adding latency, it's adding cost, right? So this capability is now available where you want to co-locate your application with your data in the same region. And finally, the third category of performance metrics is what can potentially boost your application performance. And this is by identifying if your applications are frequently accessing a small subset of your objects, right? So within a bucket or a prefix, if only 10% or 5% of your objects are being accessed every day, that's a potential candidate to be moved into a caching layer or a high-performance storage tier to improve your application performance, right? So that's, in a nutshell, the new metrics we have in Storage Lens. Again, as I mentioned, this is available in the advanced tier at no additional charge. And finally, on the simplification of analysis, we have added a bunch of new metrics. We have added billions of prefixes, support for billions of prefixes. How do we simplify the analysis? So today, the three primary ways you consume your Lens metrics is one, through S3 console. The charts I showed you earlier, these are predefined charts that are available. Second, you can publish these metrics into Amazon CloudWatch, where you can view these metrics in context with other service metrics. And the third option was to export to an S3 general purpose bucket in CSV or Parquet format, where you can then process it and start querying your data. We now added the fourth option, which is to export these metrics directly to managed S3 tables. These are automatically created for you. You can set retention periods to eliminate the data from these tables. And you can start querying right away with your preferred analytics tools, including things like MCP servers, which will enable natural language-based queries. So I've done a lot of talking about the new features. I'll invite Christy Lee to show you how these features work in real life. Thank you.
Thanks, Roshan. All right. So we're going to run through a couple of demos today. I'm pretty excited for this. The Storage Lens has been around since 2020, and ever since it launched, we've continued to improve it. Customers have just asked for more and more and more, so I'm really excited for this. But when we polled the room earlier, it seemed that there was about 20%, 30% of folks who were familiar with Storage Lens. So we're going to start at the very beginning. How do I even get started? So hopefully this view will be familiar to folks. So how do I even create a dashboard? So we browse to Amazon S3 in the AWS console. We'll go ahead and click Create a Storage Lens dashboard. You can certainly do this through the CLI, API, SDK, whatever your preference is, but we'll just show the console view for today. Many customers are, they just want to get their feet wet. Maybe they just want to start with the metric views for a handful of buckets, but you can certainly expand this out to your organizations. You can customize the metrics that you configure, being either the free tier, just dip your toes in the water, see what's available, or you can go right to our advanced metrics to see all of the metrics available to you, the 498 metrics that encompass Storage Lens. You can pick and choose which ones you want. For the demo, we'll choose all of them. But just keep in mind, these are configurable. So if later on you change your mind, you can come back and modify how your config is. For the advanced metrics, it's very popular for our customers to want to also see their prefix aggregation. This can also be customized to either the lowest being 1%, and then a prefix depth of 10 prefixes, 10 depth for white prefixes. We'll export to CloudWatch as part of this config, and then there's two different exports you'll notice here. One of them is the metrics export, which we've had as part of Storage Lens for the most part for a while now. What's new is the ability to export directly to S3 tables, which is our managed Iceberg offering for S3. You can certainly do both. You can still export the traditional way, going to an S3 bucket, storing it as a CSV or Parquet, or you can just send it straight to S3 tables, and either one, whichever one you like, or both. Once we're happy with our config, we'll go ahead and submit that. Cool, and now our dashboard's configured. Now, Storage Lens metrics, they get updated on a daily basis, but when you first create your dashboard, it will take a little bit of time to generate those metrics. So we're going to flip over to a dashboard that I pre-created, so it had some time to generate some metrics. And we're going to look through a couple of different views. So these views will sample some of the metrics. We won't have time to go through all of them. I wish we did. But we'll start off with latency improvements. This has implications for both performance as well as for cost management. As many of our customers know, whenever you go from one region to another, there are costs involved in that data transfer. If I can localize to the region that my applications are trying to access those S3 objects, I can save on those costs. The performance aspect of it being latency is if I can be closer to where I'm accessing my objects, it also means I will access those objects much faster. So we'll look at views of how to identify for cross-region access. Next, one of our most popular views, especially when it comes to cost management, is tell me which prefixes have the most access, whether it be they're very, very busy, very, very hot data sets, or maybe they are really, really cold. Maybe these are the ideal data sets for me to consider configuring lifecycle rules for and transitioning to a more cost-optimized storage class. We'll then take a look at one of the new metrics for identifying errors. We have plenty of applications, and over time, our customers have only demanded more and more and more from S3 in terms of performance. And this scales broadly across machine learning, AI use cases, analytics use cases. But being able to target down to which prefixes are seeing those errors is really insightful because it then helps me make decisions around, do I want to consider an alternative storage class? Do I want to consider caching that data? I want my applications to get the best possible performance for cost optimization because especially GPUs, I don't want them idling. Yeah. Last but not least, one of, I have a story. Yeah, we've got time. So I was working with a customer a few months ago that they were seeing like loads and loads of errors. I wish we had this view at that time where we could show them the object distributions. But what it turned out to be was they had just misconfigured their application and it was doing like these tiny little 1 kilobyte reads and writes over and over and over again. Once we found it, we were able to solve it. But with these views, we would have found it straight away. All right, let's jump into the dashboard. So the first one we're going to do is show you how do I quickly identify where are my cross-region accesses coming from. We'll do two different views of this, and we'll also show the comparison of not just cross-region, but also how those are compared to my in-region access to. So this first view shows you I've got on 2 different days some cross-region traffic that's happening. I'm now going to scroll down to the data transfer metrics, where this can help me normalize relative to all of my data access, what's cross-region and what's in-region. Now, some of you may be thinking, maybe I'm not expecting to localize this data. Maybe it's replication traffic, and I expect to have some cross-region data transfer. Not a problem. There is a filter that lets you filter out the replication bytes too. For our next view, we're going to take a look at which prefixes have the most access. Tell me where are my hottest possible data sets. We'll flip over to the prefix tab to do this. And once it loads, here we can quickly get a graph as to what requests are happening on my bucket. Now, typically for customers who are operating at scale with hundreds of thousands of TPS, they're also going to be a little bit worried about potential errors. Am I seeing errors? Am I seeing retries because of these high request counts? So we'll filter for our concurrent put 503s, and we can see, yeah, there's some traffic going on there. That's a little concerning. But maybe I want to go and normalize that as well. Tell me, how much percent of all of my total requests is because of those current clicks. So we can see for this particular prefix we've highlighted, about 0.03%. It could be better. Not too bad, but it could be better. We'll now use the filter view to zoom into one particular bucket where we know that we're seeing some of these errors as well as some of these high requests. And the view we're going to highlight here is the object size distribution. All right. So down in this graph, we can see the object count, the object reads, and the object writes across the different size distributions. This is where I can easily see how many of my requests are those really small objects. Maybe I've got those little 1 kilobyte, 2 kilobyte, 4 kilobyte objects, up to all the way at the other end of the scale, where I'm doing accesses to gigabyte objects. So this is an easy way for us to get that. We could certainly derive this from server access logs or other insights solutions. But from here, it's just really quick and easy for me to just gauge what's happening at my prefix. All right. So hopefully that gives folks a quick taste of what they can do with the dashboard views that are now available. We'll now look into what we can do with the S3 tables exports for the storage lens metrics. One quick note is we've had the export to the S3 general purpose buckets for some time now. And this includes, I store it as a CSV, I store it as a Parquet, and then I can ingest this and consume it however I'd like to. So one question I expect that our customers will have is, why should I choose exporting to S3 tables? So one of the benefits is I can connect it to our existing analytics services. Maybe we're already comfortable using or interacting with Iceberg. But the other benefit of S3 tables is that I'm going to have that managed compaction, managed snapshot management that I typically wouldn't need to worry about, but I don't have to worry about for S3 tables. Because of the way we've segmented out the metrics, we've split these out into 5 different tables. The first one being the bucket property metrics. This is going to be, what are my default settings on the buckets I've got configured. Next will be the default storage and the default activity metrics. Remember in the dashboard, we configured that aggregation of 1% prefix step 10. That's what's going to be included in that default storage and activity metrics. Now, for the view that Netflix is probably most excited about is our expanded prefixes, storage, as well as activity metrics. This is going to be that prefix depth of up to 50 and unlimited prefixes, so you can get full visibility of what's happening across your buckets, accounts, and organizations. All right. So for this demo, we're going to choose to use Athena as our preferred analytics tool, but you're certainly welcome to use any that works with S3 tables. We're going to run a couple of different views just to show what you could do with the metrics. So in the tables, which will be automatically configured for you as part of the S3 tables integration, you can preview what metrics are available for both the default as well as the expanded metrics. So I've pre-set up a couple of SQL statements, so we'll just pop those in and run those. And the first example we're going to look at is for our default activity metrics. We're going to go see if we can find where there are 503 errors that are happening on my bucket. This is for where I think I might have some hot data sets, hot prefixes, and I might want to consider moving that to a cache or more performance storage. So from here, I can quickly see I've got about 800-something results. Remember, this is going to be my aggregate for some prefixes, but not all of my prefixes, and certainly not any that are beyond 10 in depth. If I flip this now to my expanded prefix activity metrics table, I can see all of my prefixes. So independent of size or independent of depth, I'll be able to get a full view across what I've configured for my storage lens, all the prefixes that I want to get visibility into. All right. So pretty neat, a quick and easy way for me to get that granular visibility. For our next example, we're going to take a look at the cost management aspect. So this is typically going to be, how do I find the coldest prefixes? How do I find the largest prefixes? Where am I going to get the best possible savings across my organization? So we'll do a quick search here for the activity metrics where I can sort by number of requests. However, I've only looked at the activity metrics. I haven't really been able to contextualize this because I want to be able to also sort based on prefix size. Some of these prefixes are going to be pretty small, some of them are going to be much larger. So what we can do here is a neat little table join between our storage metrics and activity metrics, give me the largest prefixes by size, and then give me the number of requests that I'm seeing across them. Yeah. So we'll just highlight that, make sure the join's happening upon the prefix. We'll give that a few seconds to run. And then once it finishes, we'll be able to see where are our largest prefixes that are really, really quiet. There we go. All right, so we've got a slightly different view. We still get the same number of results, because we're still showing all the prefixes, but this time we get a top 10, top 20, top 30 list as to which are the prefixes where it's really cold, and I'm going to get the best value trying to optimize it. Often, this is where customers will want to go work with their application owners to say, hey, this is your prefix, this is your bucket. Do you want to take another look at that? So this really empowers you and gives you the data to do that. All right. So for our final demo, we're going to take a look at how do I use natural language to go interact with my storage lens metrics. For the demo, I'm going to set up an AI code assistant. You can certainly use your preferred AI code assistant, whether it be Amazon Q. I've used Cura in my demo. There are popular ones out there. But we're also going to connect it to a Model Context Protocol server, so an MCP server, so that we can actually have the AI code assistant through the LM understand external data sources. It's going to be interacting with S3 tables, but since our storage lens metrics are stored in S3 tables, it means we can interact with it that way. All right, let's get into it. So first, I just want to show you how do you set up Cura. Cura was launched a couple weeks ago. If you're familiar with VS Code, its IDE is inspired by VS Code, if you like. So pretty quick and easy to set up and to get started with. In this vanilla Cura install, I'm going to start off by prompting it by asking a question of what S3 tables live in US East 2. It's going to try to figure out what I'm asking there. It's asking me about tables, it's asking me about buckets. So really, I've not really configured the MCP server, so it doesn't really know what to do. So let's go fix that. The first thing we'll do is put in the config for the S3 tables MCP server. The only thing I need to make sure of is I give it the appropriate credentials so it can access my AWS account. So once we've got that set up, we can then save it. And I'll just expand out on the left that there are a number of queries that it now understands that it can run in terms of APIs to interact with S3 tables, and it's going to take advantage of that as part of our prompts. So just to show that it's now working, we're going to ask it the exact same prompt again. What S3 tables are in US East 2? OK, excellent. So we know it's able to use the MCP tool we've just configured. It knows that we want to talk to US East 2, and it's going to wait for me to give it permissions. OK, there we go. Yeah. You can set it to not prompt you, but for this demo, we've got it prompting us. OK, excellent. It's been able to find a couple of namespaces. Some of these are storage lens related. Not all of them are, but some of them are. We're going to next prompt it to go look at one particular namespace where we know I've got my storage lens configured for all of my buckets. I'm then going to ask it essentially the same question I was running in the Athena queries of give me my top prefixes sorted based on size with the lowest number of requests. We're not going to tell it where exactly to look aside from the namespace, but we'll try to let it figure it out. So what's nice about this is it's going to have very minimal human interaction. I've just given it the prompt of tell me where my lowest prefixes are. And it's going to do a little bit of discovery. It doesn't really know anything about the schemas or what's inside of those tables, so it's just going to run some select statements, try to find out what's available in there. What kind of metrics can I derive that will essentially tell or answer the questions that the user's looking for. It's going to peek at both the storage metrics, where I can get my usage trends, but it's also going to peek at the activity metrics, where I'm going to get the API requests that I care about as well. We already know that a join is going to need to happen in order for us to be able to connect both my prefixes based on size, but also the requests. But we haven't told the coding agent that it needs to do that. We're going to let it figure it out on its own. So sometimes it'll go back and forth a little bit. All I'm doing at this point is just clicking, yes, go run this command, yes, go run this command. And it's trying to create the appropriate SQL statements so that it can essentially find out the answers to the questions about largest prefixes with lowest number of requests. OK, perfect. So it took a couple of select statements, but it eventually got there, and it was able to print out the buckets and prefixes with the largest size that have very minimal requests. Pretty cool. So all of this without needing to necessarily know about the schema, not necessarily needing to be a SQL expert. I can get started very easily with natural language to go query my storage lens metrics. Right. And with that, we thank you all for joining us today. A couple of key takeaways that I would hope to impart on all of you is that if you haven't tried Storage Lens yet, please take a look at it. It is part of our Storage Insights portfolio across, we've got our logging solutions, we've also got our holistic usage views as well through Storage Lens. We've expanded out the number of metrics that are available to you, so please do check them out. The free metrics are a great way to get started, but you can also experiment with the advanced metrics. For customers who have a larger footprint or want that granular visibility, there's expanded prefix metrics can be opted into so that you can get full prefix depth and unlimited prefixes. Sorry, not full prefixes, 50 depth for your prefixes and unlimited prefixes. There are additional cost and performance optimizations that you can get from the 72 new performance metrics that are included in the advanced tier. Last but not least, have a look at the S3 tables export if you want to take a look at that natural language processing or taking advantage of the analytics tools that are available to us. So hopefully that gives you a good place to start. I thank you all and hope this session was informative.